Hello viewers, once again welcome back to Java Jagaran. Um, as part of collection video series, today I'm going to talk about the custom linked list. So in my previous video, I have talked about the internals of linked list. So how the internal linked list works internally and at all. So I discussed those things. So as part of this video, I will be discussing about the creating our own linked list. I will show you by creating our own linked list. So I will show you. I will be linking from the previous video, and I will show you all the things how to implement our own linked list and at all. So let's start with that. First of all, these are the methods I'm going to implement in our custom uh, linked list. So I will be creating one custom linked list. On that, these all the method will be there. So this 17 method I will be going to implement there. So let's start with that. So for the time, due to the time constraints, I'm not going to create all the methods linked list here. I have already created a linked list. What I will do is I will explain the each and all the things here. So how I did it, like, so let's start with that. So here I have created one class which called custom linked list. So I created one class custom linked list, and I provided one zero param constructor for this. And after that, because I didn't provided any parameterized constructor with the size or something, because that all the thing happened in the case of array list only, because array list internally store the data in the form of array, and internally it's follow the data structure called growable array. So for that we need a size, initial size or incremental size, etc thing, because based on that they will be going to increase and create the array. But not like same. Linked list is a different. I already discussed. It's internally following a linked list data structure, so it's not required of say size and at all. How many objects you will be adding? It will be keep growing and keep growing until or unless the your memory will get full. It will be allowed to adding the data on that. So for that, I'm created one class called node. So this one will be using this. I will be make a linked list. So the first, before starting, I can say about the linked list. Linked list internally following a data structure called doubly linked list. So it will be doubly linked list. Who people might have learned in the DS chapter. Like the EBD node will have the address of the previous node and next node both. So that's how. So if and at any point of time, if you had to go into the either direction, it will be able to go either in forward or backward direction. So for that I created one class node. This one will be the, and each the data is called node. So it will be having the three property. One is called here I am using the generic, so that's why I put the e. So here it's the object that will be storing the object whatever the data we are going. I named it like item, and there will be a two more object of the node class same. So it will be pointing to the this one will be pointing to the next node, and this one will be pointing to the previous node. So it will become the doubly linked list. And for the easy purpose, I created one constructor with the three argument. So that will be first it will take the previous reference, then element, then the next reference. So I will be using this node class for storing the data and all implementing the linked list data structure. So for that, in the class level, I created two variable. One is called first, one is called last of the node class. So why I created this one is I can manage with the one also, but if you will see in the linked list that is provided by the Java people, or for the better utilization, I created two one. So why two one? One will be pointing from the beginning, and first one will be pointing from the beginning to the list, and last will be pointing to the last of the list. So anytime as we people have saw, like, see, here will be method like get first, get last, remove first, remove last, add first, add last. So some operation we have to do from the beginning, some operation we have to do from the ending. So if you I will be containing the only the address of the beginning. So if you have to add anything from the last, then it will count the so many times I have to travel. If the already 1000 data is added into the linked list, so I have to travel the 1000 data, then after I will reach to last. So that will decrease the performance. That's why I created one two variable, one is the first and one is the last. So based on the requirement, I can use both to travel the. If you have to do some operation in the last, I can directly refer to the last, or if I have to do some operation in the beginning, I can directly refer to the first. And apart from that, I have one integer variable called size that will be counting the size. So how many data available in the linked list. So this will be counted through this one. So like this I created. So let's just start with the discussing each and every method. So first I will be discussing about the get method. So let's just start with the get method. So what I did like get. So if you have seen like not get, let's start first with the add method. So I'm going to first start with the add method. First I will show you about the add method, how to add the delta element into the linked list and etc. So let's start. First is the add with the object. So whenever we are calling the add method with object, so what it will do, if you will see the structure also in the functionality, whenever you are calling the add method on the linked list, it's going and adding into the last of the list. So that's why I didn't wrote the logic for the myself again. So just what I did, just I call the add last method, so it will be adding into the last one. So let's see the add last method. So what the add last method is doing here, it's created one reference called L, and it's started pointing to the last one, whatever the in the top we are having. Then what it will do, it will go and create one new node, and in this new node I'm calling the I created one constructor already, I shown you. So what I'm doing is like the last one will be the this last. So for the already suppose one node is there, so we are going to add the new data to next to that one. So existing data will become the previous one, and the new node become the next one. So for that what I did, I'm passing here L. So last reference I'm passing here. So our new record will be internally started pointing to the last existing last record, and E element whatever the data I have to add, that one I'm passing into the middle. And because on it's going to become a last record, so that's why in the ending no one will be, so no next record is there, that's why I'm pointing to the last, and the last will become the new node. So this new node will last reference will start pointing this new node. So this one, now this new node become the last object, and the previous last one will be pointed to the previous of this node. And if the L is equal to null, it means the if the already no data is there into the list. So what I am doing, the first equal to no node. So if already no data is there, so what is the happen will, the same will become the first and the last node only. If the already data is there, so what I am doing, so already whatever the last record previously before adding the element is there, on that the next will be the new node. So previously suppose fifth element is there, so now fifth will be started pointing to the new node that we are adding to sixth one, and the sixth one previous will have the fifth node address. So this is how it will got linked to into the doubly linked list. So this is all about the add last method and the add method also. So these two method is over. Now let's, before talking about the add to a specific position, I will be talking about the add first. So same like the add last also, what I will do, add first is, I created the local reference, and on that I complete the reference, started pointing to the same object that is pointing to the first, and created one new node. Here in the previous I'm not passing, here I'm the previous I'm passing null, because if I'm going to add into the beginning, so for the first record no previous record is there, because that one only the first record, so that's why the previous will be null. And in the element, the whatever the data we have to requested for the add will be there, and on the next node it will be whatever the existing first is there, that one become the next node. So for this node and the next first node become the this new node. So what will happen? New node become the first node, and the new node having the next address, that one become the existing first node. So this is how the new node become the first node and the existing new node become the second node. So this is will how it will got linked. And if the f equal to null, it means no data is added previously into the linked list. Then what? The last one will be also the new node. So same like add last, first and last both will be pointing to the new node only. Else, if the already data is there, so what it will happen? So already whatever the existing data is there for that existing first node is there, for that previous one become the new node. New node become the previous one, because we have to maintain the doubly linked list. That's why we are doing this one here. So this is all about the add first and add last and add with this object. Now let's start talking about the add with the two parameter, that is the index and element. So this method will be responsible for adding the data at the any specific function. So how it will do? Initially what I am doing, I am checking if the index is between 0, it's less than, if the index is less than 0, or index is greater than or equal to size. So on that case what you have to do, you have to throw exception called index array out of bound, because if we are passing any negative number, that one also should be wrong. Or if size is 5, so if size is 5 means you all know that collection follow the zero based index. Size is 5, it means already 4 the element is only there, and you are calling to add into the 5th or 6th location. So how it will do? It will be it's not possible. So in the middle it will, the gap will come. So that's why I'm throwing the index array out from count exception. Else if it's not there, if it's not satisfying this condition, so it will come to down. And if the index is equal to the size, so if the index is equal to size, then what we have to do, we have to just call, because it's calling the sorry, one correction is here, it should not be the equal, it should be a less than only, because if it's calling to the size, if you can simply, if the 4 element is already there, so size is the 5, and we are calling to the add to the 5th location, so it can go and add at the last location, it means the 5th location. So on that case this one should be 1. So if the index whatever we are going to call to the add and the size is the equal, so simply call the add last method, so it will go and add it to the last one. Else it's not there, then what we are doing is, we created one local reference and we refer to the first, and from the first we start traveling. See here, I equal to 0, I less than index, till the I less than index, I plus plus. So what I'm doing, I'm keep on increasing I. So and what I'm doing, x equal to x plus next, x equal to, sorry, x equal to x2 of next. So what it will do, every time it will be keep increasing, loop will be running, and x will become the start point to the next and next address. After it will reach to the index one, what I'm doing, I'm suppose we are calling to the third index. So what it will do, it will go to the till the 0 1 2. Suppose it will go to the 2. Now x1 will be pointing to the second index. So what it will do, it will, in the I created one pref, in the pref what it will do, that it will be pointing to the x previous address, and uh, it will be for the previous address, it will be containing the whatever the previous node is there. So x pref, it will contain the previous address. Now I'm creating one new node. What it will do, it will from the previous, it will be pointing to the that pref node. So whatever the index we are calling to add, before that whatever the record is there, it will be started pointing to that one. And this on the middle element will be there, and for the next what will be there, that index element will be there. So what it will become, so in the suppose third index is there, so what it will, third index will become the next, will come into the next one, second will come into the previous one. So this new element will become the third index element, and their next element will become the fourth element. So this is how it will got linked. And after that what I am doing, x dot pref, so whatever the already x is there, so on that pref node I am adding the new node. And if the pref equal to null, it means if it's the first record, so what I am doing, pref is the null, it means that what, it's the first record. So on that case, what I am doing, first equal to the new node. Else, if it's not a first record, then go to the previous next, and on that it will add to the new node. So what it will do, it will on the existing previous one, it will start adding the new node. So this is how it will work, and the size will keep on increasing. So on the every method you add method, you have seen that I will be increasing the size, so I can keep track of that. So how many data are added into the linked list. So this is all about the add method. Now let's talk about the get methods. So how the get method works? So get method is pretty easy. It's not complicated. Simply, if whatever the index you are requesting, if it's greater than sorry, less than 0 or equal to greater than size, then simply I will be throwing an index array, index out of bound exception, because it's the data is not there for that index. Else, what I am doing, I keep the first node address in the X, and I will keep on going to till the that index. And what I will do is I will get the data of that index X dot next. I will be keep on and the X keep on assigning X dot next. So it will, every iteration it will be start pointing to next node, next node, next node. And whenever it will reach to the index, what I will be doing, I will be returning the item of that index, so that data will get returned. This is how the get with the single in parameter will work. Other one is the get first. So how the get first will is simply get first is the nothing. Simply if I will be pointing to the first address, and if the first is null, it means the no data is there already in the linked list. So on that case, what I will be doing, I will be simply throwing a exception called no such element exception. Else, if it's not a null, it means that first element is having data, then simply I will be returning the item of that data. No. And the same like the get last also, I will be start pointing to the last one. And if the last one is a null, I will be throwing like no such element, because there is no data. Else, I will be simply return the item of that node. So this is how here the useful are the first, why I kept the two reference called first and last. Else on the last, here I have to travel from the beginning to till the last by looping it. Then I can get the last node. Then I can. So for that one, for the memory saving and the time saving, I did like this. So this is all about the get method. So next I will be talking about the remove method. So there are four remove method. I will be talking about that. So first one is the remove with the object. So what is the remove with the object? So if we are calling remove with object, and the object is having a null. So for null, I separated it. If the null for I will be doing this, and for the not null things I will be doing this. Because for the comparison we have to call the equal method, and on null if we will be calling a equal method, it will be count the null point exception. So that's why I keep two different flow, two separate flow for the null value and not null value. So in the case of null value, what it will do, I will start. I created one for loop. It will start pointing to the first until or unless x become null. Keep on doing x equal to keep on going to x equal to x to next. So it will keep on pointing to the next node, next node, next node. And middle of that, I will be also what I will be doing like, if anywhere I found like item equal to null, if we are searching for the null and anywhere we found the data is null for that node, so on that case what it will do, I will created one helper method called unlink, because I have to use the logic at several places. So that's why I'm not writing the logic again and again, and I created one method, I will be using that. So what the unlink will do, unlink will simply will it will get the node, and what it will do, it will create one element, because it has to return the element. So it will keep one element, and it will keep the element of that node. And what it will do on the next, it will do the x to next, and the previous it will do the store the x to previous. And if the previous equal to null, it means the previously no data is there on that, it's a first element. What it will do, first equal to next. Or if the next equal to null, it means if it's the last record, so what it will do, last equal to prev. Else it's not like that. If we are removing from the middle, so on that case what it will do, it will simply it will assign to the previous node's next address as the next, and the x dot previous equal to null. This is I'm doing for the garbage collection. So garbage collection should be able to the garbage collector should be able to delete that node, that class object. And in the same case, if the previous is next is equal to null, it means if it's the last record. So what I will be doing on the previous of the next, I will be assigning to the previous. So this is how the unlinked method will work. And now let's come back to the method called remove with the object. So it will be keep on searching. If whenever it will found the matching null, it will return the it will call the unlink method, and unlink method will unlink that, remove that one node, and it will return a true. So this is how. Else, if it's calling the remove method with some object, so on that case, what it will do? Same, it will keep looping, keep to the going to the next object, next object, next node, and the every node it will be keep calling the equal method. Wherever the equal method will return the true, it will wherever it found that that object, what it will call? It will simply call the unlink method with that node. The unlink method will remove that node from the linked list, and it will return the true. If either if you null requested and didn't found, or object requested or didn't found, so on the last it will be returning the false, means we are not able to remove that object because we don't found that object whatever you are requesting into the linked list. So this is how the remove with the object will work. Other one is remove with a single index. So same like remove with single index, how it will work? If the index is whatever you are requesting, that is less than 0 or greater than equal to size, it means for that index no record is there. So on that case, I will be throwing the id index out of bound, sorry, index out of bound exception. Else what I will be doing, I will keep the first record, and from the first record I will be keep traveling to the till that index, and whenever I will reach to that index, I will call the simply unlink method. So unlink method, what it will do, it will unlink that record, and then I will be returning the x dot item. So whatever the object is removed, it will be returned. After that, the other one is the remove first. So remove first is the pretty simple. If the first equal to null, it means already no data is existing. If you still calling the remove first, it will throw the exception called no such element exception. Else what it will do, it will keep one element on the next node. I will be pointing to the existing items, first nodes next will become the null. I will point to the next, and now this next will be pointing to the first. So the next second element will become the first element, and the first element item and the next both I am keeping as null for the garbage collector. And here next equal to if the null, if the next equal to null, it means whatever the next equal to null, it means if there already the only one data was there. So in that case, what I will be doing, last equal to null, and next of previous equal to also null. So uh, yeah, sorry, if the only one data will there, so last one become the null, or on other case, next node's previous address will contain the null, and I will be returning that element. Same like the remove last will also work. If the we are requesting for the last one is the null, so there is no data, so we can throw the not such element exception. Else what we can do, we can keep that previous nodes, and we can make become set that to null for the garbage collector, and the last one become the last previous one become now the last one. So it will last one will be able for the garbage collector, and the same like the remove first remove last will be working. And there is one also method with the simple call remove without parameter. So it's if you the functionality of the remove without parameter is the same like a remove first. So it will be removing the first element. So this is what about the remove method. So next method is like set. So we can update the any nodes value, we can set the override the value for the existing. So for the same like what I did, if the index is between 0 less than 0 or greater than equal to size, so I'm doing the index out of bound exception. Else I will keep traveling to that till that node for which node I requested the index one,
And what I will do, I will set on that index item data, I will be set to the newer data, and the old data will be returning from. So this is the set on. And the next one is nothing called index of method. So index of method will be for the searching purpose. So same like get also, here if we are finding for the index of null. So for the null and the not null, I keep the two, both are different flow. If there is null, so what it will do, it will keep traveling from the first node to the till the next, keep next until the it reaches to the last record, and it will keep the increasing the index. So if the x dot item equal to, it will found the null, it will simply return that index. So it will become that, yeah, suppose you found a null on the fifth index, so it will return that fifth index. It will return the fifth, else it will keep increasing the index. And if it's not found anywhere, so on the last, what I will be returning like minus one. So minus ones means simply like we don't find that element in the link. Else if you are calling for the object, so for object we simply nothing will be changed, just instead of comparing null, we will calling the equal method. And if equal method will returning true, means the element got found, and the same logic will be same like null. And the same like the last index of also. So index of and last index of is, index of will start looking from the first, and the last index of will start looking from the last. That one only the different. Apart from that, nothing will be the difference. The same logic will be the same. And the contains method will be also the same. It will simply call the contains method. What it will do, it will used to do like if the object is found, it used to return the true, else it will return to the false. So simply like I'm calling here the index of method, I'm not writing the logic again. And if it's not equal to minus one, if the it means the index of method used to return minus one only if not found the object. So same like if it's record the return the minus one, I will return the false. And if it's not a minus one, then I will be returning the true. So this is all about the contains method. Else we are having the iterator. I wrote one iterator for the iterating the record. So this one is not much. I just created one inner class and implemented from the iterator and implemented all the method. So the this one already shown to you people, and I overridden two method, string method for returning into the better way. So this is all whatever I implemented. So next, I could show you by running this class at one shot and quick manner. So I created one a student class which having the ID and name, two property, and it will overridden the two string method and equal, because equal method I return if you are using any object, custom object into the collection. For the better performance, you must have to override the equals method. So now let's run this class. Apart from that one, the all the is okay. So here I am calling the three add the three method. So see in the first line the three object is they are added, got added. Now I am calling add at the first location. So what the fourth element is got added at the first location. Now after that I am calling add first as student id 5 and add last with student id 6. So add on the first index the student id 5 will be there, and on the last index the student id 6 will be there. And apart after that I will be calling like get first and get last. So let's see, get first, yeah. So get of first, so get of at the first index what is there, ram this object is there, so it's got returned. Get of first is there, so on that john is there. And if you are calling the get of last, so on that what will be there, this smith will be there. So this one will be getting returned. After that what I did, I added some more object, and after that what I did, I remove up to. So remove up to is before the removing, I could show you there is on the second, yeah, second location, this was is there, id 4 is there. So after the removing, this next one will become the second one, and that one got removed. Same like remove with object called 3. So before calling that one, the 3 was Yeah, here it was there. So after that it will get, because the 3 I added Mohan 4 times, so that's why. See, one is there with the 3 index, and here one another with the 3 index. So this is how it will be working. Same like the remove first also. So this is how the remove first, see, if the first record is there, so in the next line first record got deleted and the second will become the first. And same like remove last also will be, see, here the Mohan was there, so now the Mohan is got removed and the Sam will become the last object. And the same like set of the say at the second location I'm setting like 22 Java Jang. So it will be setting like on the second location 0, yeah, on the second location it will set like 22 Java Jang. So this is the all how it's working, and the index of last index of method all it's working. Like, see, on the 5 one RAM is there on the 15 index. So if you will see on the 15 index there is the RAM is there, yeah, on the 15 index RAM is there. So same like on the index or we are containing or the equal method, so these all are working. So hope so this will help you people. Keep watching the video. If you like, write comment and share. That's all for now. Thank you.